Look up tonight. Find the constellation Orion. You will see his shoulder, a faint reddish star glowing at the top left, slightly dimmer than usual. Slightly wrong. That star has a name, Betelgeuse, and it is dying. Not slowly, not peacefully, not in a distant, abstract cosmic timeline you will never live to see. It could explode tonight. It could have already exploded. Right now, as you read this, the light from that detonation might already be racing across 700 light-years of empty space, closing the distance between us at 300,000 kilometers per second. We would not know until it arrives, and when it does, Betelgeuse will become so bright it will cast shadows at midnight. It will be visible in daylight. For weeks, there will be no true darkness on Earth. No night. Every civilization that has ever stared at the sky will be forced to confront the same question we are about to answer. What is this thing? What is actually up there? And what happens when it finally goes? This is Betelgeuse, and nothing in your life has prepared you for what it really is. Part 1. The scale of a monster. Most people, when they think of a star, picture the sun, a burning ball of gas, massive, incomprehensible in human terms, 1.4 million kilometers across, a million Earths packed inside it. The sun is a mosquito. Betelgeuse is a red supergiant. The word supergiant sounds like marketing. It is not. It is a clinical description of a class of object so large that language genuinely fails to describe it. If you placed Betelgeuse where our sun sits right now, its surface would extend past Mercury, past Venus, or past Earth, past Mars. It would swallow the asteroid belt entirely, and its outer layers would reach, depending on the day, all the way to the orbit of Jupiter. Jupiter, the gas giant so large that all other planets in the solar system could fit inside it. That is how far the surface of Betelgeuse extends. We live 150 million kilometers from our sun, and we complain about the heat. The surface of Betelgeuse is 700 light-years away from Earth, and on a clear night, you can see it with your naked eye. It is one of the largest stars visible to the human eye, possibly the largest, and it is not just big. It is unstable, violent. It breathes. Betelgeuse pulses. Its surface heaves in and out like a living thing, expanding and contracting over cycles that last months or years. The massive convection cells, each one larger than the sun itself, rise from deep inside, boiling up through the outer layers like slow-motion eruptions of unthinkable energy. The surface of Betelgeuse is not a smooth shell. It is a churning, boiling, asymmetric mess. Hot spots blazing, cool patches dimming, giant plumes of gas ejecting into space and raining back down in slow avalanches of plasma. It is not a star. It is a barely contained catastrophe. Part 2. The Great Dimming. In late 2019, astronomers noticed something wrong. Betelgeuse was dimming, dramatically, measurably, in a way it had never dimmed before in recorded history. By February 2020, it had lost more than 2/3 of its brightness. A star visible to the naked eye for all of human history was fading before our eyes in real time, and astronomers called it the Great Dimming. The internet called it something else entirely. The headlines were everywhere. Betelgeuse is about to explode. The supernova is coming. Brace for impact. Telescopes across the planet swung toward Orion. The Hubble Space Telescope was redirected. Every major observatory on Earth trained its instruments on a single point of reddish light in the winter sky, waiting. And then, slowly, Betelgeuse brightened again. It did not explode. Not then. But here is what we found, and this is where it gets genuinely terrifying. The dimming was not random. It was caused by two separate, simultaneous events happening at the same time, layering on top of each other. First, that one of those massive convection cells erupted, a surface mass ejection so enormous it threw a chunk of plasma the mass of several times our moon into space. This gas cloud cooled as it traveled and condensed into a gigantic cloud of silicate dust, essentially a temporary smokescreen orbiting Betelgeuse, blocking part of the star's light from reaching us. At the exact same time, a natural pulsation cycle was hitting its low point, dimming the star from below as well. Two events, at the same moment, both independently dimming the star. The odds of that coincidence are extraordinary, or it is not a coincidence at all, because something is changing inside Betelgeuse, something that may have been building for a very long time. Part 3. The Engine of Death. To understand what is happening to Betelgeuse, you need to understand how stars work, because a star is not burning. It is not fire. It is something far stranger. A star is a war. In one corner, gravity, the relentless, patient, crushing weight of millions of years of accumulated mass pressing inward from every direction simultaneously. Gravity wants to collapse the star. It always has. It never stops trying. In the other corner, nuclear fusion. The core of a star is so hot and so dense that hydrogen atoms are forced together violently enough to fuse into helium. That reaction releases energy, outward pressure, that pushes back against gravity. For most of a star's life, these forces are in perfect balance. The star holds its shape. Millions of years pass, billions for smaller stars. The hydrogen burns, and then, one day, the hydrogen runs out. For a massive star like Betelgeuse, this is not the end. It is the beginning of a desperate, accelerating chain of compromises. With hydrogen gone, gravity surges. The core collapses until it gets hot enough to fuse helium. The helium ignites. The star expands into a red giant, bloating outward as the new fuel source burns. Then the helium runs out. The core collapses again, heating further, until carbon ignites. Carbon burns, then neon, then oxygen, then silicon. Each stage is shorter than the last. Hydrogen fusion in a massive star takes millions of years. Helium fusion takes hundreds of thousands. Carbon burning takes centuries. Oxygen, months. Silicon, days. Each new fuel burns hotter and faster and more desperately, like a fire consuming increasingly expensive fuel to stay alive. And at each stage, the core grows denser and stranger, layering like an onion, silicon burning on top of magnesium, on top of oxygen, on top of neon, on top of carbon, on top of helium, all surrounding a core of pure iron. And here is the trap. Iron is the end of the road. Every element up to iron releases energy when fused. Iron does not. Fusing iron actually absorbs energy. For a star in its final hours, iron is poison. When the core of Betelgeuse finishes fusing silicon into iron, the iron simply accumulates. It piles up. The core grows denser and denser until, in a fraction of a second, less time than it takes to blink, gravity wins the war it has been fighting for 8 million years. The core collapses. Part 4. The last second. What happens next is the most violent event in the observable universe. And the iron core, roughly the mass of our sun, but compressed to the size of a city, collapses in less than a second. The outer layers of the star, still burning, still falling inward, suddenly have nothing to fall into. They slam into the newly formed neutron star at a quarter of the speed of light. The rebound is cataclysmic. A shockwave explodes outward through the star with more energy than our sun will release in its entire 10 billion-year lifetime. This is a supernova. In those first seconds, Betelgeuse will release more energy than 100 billion suns. For a brief moment, a single exploding star will outshine the entire Milky Way galaxy, every one of its 400 billion stars combined. The outer layers of the star, the gas, the plasma, the iron and oxygen and carbon and silicon synthesized over 8 million years, are blasted outward at 10% of the speed of light, 30,000 kilometers per second. They expand into space as a growing shell of superheated debris, a supernova remnant, still visible thousands of years later as a glowing nebula. And the core, it collapses further into an object so dense that a teaspoon of its material weighs 1 billion tons, a neutron star, or, if the mass is sufficient, a black hole. The shoulder of Orion becomes a tombstone. But here is the part that should genuinely unsettle you. Before any of that light reaches us, something else does. Neutrinos. In the first 10 seconds of the collapse, Betelgeuse will release more energy in neutrinos than in all other forms combined. These particles travel at nearly the speed of light and pass through matter as if it does not exist, and will arrive at Earth hours before the visible explosion. We will detect them. We have detectors buried deep underground, specifically waiting for this signal. The Ice Cube Neutrino Observatory in Antarctica, the Super Kamiokande detector in Japan. When Betelgeuse goes, these instruments will scream simultaneously. We will have roughly 2 to 3 hours of warning before the light arrives. 2 to 3 hours of knowing it is coming before the sky changes forever. Part 5. What happens to Earth? At 700 light-years away, Betelgeuse is far enough that it will not kill us. Let's be precise about that. The distance is sufficient, but the experience of it will be unlike anything in the history of human civilization. For weeks, possibly months, Betelgeuse will be visible in the daytime sky, and not as a faint smudge, as a distinct, brilliant object. A second sun, dimmer than the real one, but undeniably there, a fixed point of searing light in the blue sky. At night, it will cast shadows, clear, distinct shadows. You will be able to read by Betelgeuse. Look outside at midnight and see your own silhouette stretched across the ground, thrown by the light of a dead star 700 light-years away. Every culture on Earth will react. Every religion will interpret. Every government will make statements. Every child born in those months will grow up hearing about the night the sky changed, the night a new star appeared and refused to leave. Astronomers will be ecstatic and overwhelmed. Every telescope on the planet, every satellite, every instrument humanity has ever built for looking at the sky will be trained on a single point of light. We will learn more about stellar death in those weeks than in all of prior human history. And eventually, over weeks and months, the light will fade. The supernova remnant will expand. Where Betelgeuse was, there will be a cloud of glowing gas, slowly growing, slowly dimming. In a few thousand years, it will look like the Crab Nebula, the remnant of a supernova observed by Chinese astronomers in 1054 AD, still expanding today, still visible. And at the center of that cloud, invisible, unimaginably dense, a neutron star spinning hundreds of times per second, a pulsar, the collapsed core of what was once the shoulder of Orion. The constellation will be changed forever. Orion, one of the oldest stories in the sky, will be missing a shoulder. Every culture that has used those stars for navigation, for mythology, and for measuring the seasons, they will look up and find a gap, a permanent absence, a scar in the sky. Part 6. When? This is the question everyone asks, and the honest answer is maddening. We do not know. Astronomers estimate Betelgeuse will explode within the next 100,000 years. That sounds like a long time. On human timescales, it is. On cosmological timescales, it is nothing, a rounding error. An eye blink, a fraction so small it barely registers. But 100,000 years is not the whole picture. Some researchers, looking at the acceleration of its instability, the increasing frequency of its pulsations, the unusual behavior since the Great Dimming, suggest it may be significantly closer to the end than that estimate implies. And there is a deeper problem. We are watching Betelgeuse as it was 700 years ago. The light arriving at your eye right now left that star in the 1300s, while the Black Death was still sweeping through Europe. Whatever is happening to Betelgeuse right now, the state of its iron core, the progress of its silicon burning, we will not know for 7 centuries. It is entirely possible that Betelgeuse has already exploded. The shockwave may already be traveling toward us. The neutrinos may be years away from arrival. The light that will flood our sky may be, right now, racing across the void. And we are simply waiting, without knowing it, for a message that is already on its way. When you look at Betelgeuse tonight, you are not seeing a star. You are seeing a photograph of a star, a portrait taken in the medieval ages, printed in light, delivered to your eye across 700 years of empty space. Was it you do not know what the original looks like anymore? Nobody does. Part 7. What Betelgeuse made. There is one more thing, the most important thing. Betelgeuse did not just arrive in the universe burning. It built something. It manufactured something. Over 8 million years of nuclear fusion, it synthesized elements, carbon, oxygen, nitrogen, silicon, iron, from simpler ingredients, forging them in its core the way a blacksmith forges metal. When Betelgeuse explodes, all of that material is released, blasted outward into space. It drifts across the galaxy for millions of years, mixing with other gas clouds, slowly condensing under gravity into new structures, new disks of material, new solar systems, new planets. The iron in your blood was forged in a star that exploded before our sun was born. The calcium in your bones, yet the oxygen in your lungs, the carbon that forms every molecule in your body, none of it was made here. All of it was made out there, in the cores of massive dying stars, and scattered across the galaxy in supernovae, identical to what Betelgeuse is about to produce. You are not watching a star die. You are watching the mechanism that created you. Betelgeuse dying is not a tragedy. It is a delivery, a cosmic manufacturing event that will seed the galaxy with the raw ingredients of future life. Somewhere in the expanding cloud of a Betelgeuse supernova remnant, in 500 million years, a new solar system will condense. On one of those planets, in perhaps 1 billion years, something will look up and wonder where it came from. Closing. Go outside tonight. Find Orion. Look at the top left shoulder, that reddish-orange point of ancient light. You are looking at a star that is already in its final chapter, a massive, unstable, pulsating colossus 8 million years old, 700 times the size of our Sun, running out of fuel and running out of time. A ticking device of unimaginable scale, pointed at nothing in particular, primed to release more energy in 10 seconds than our star will release in its entire lifetime. It is one of the most spectacular objects in the observable universe. It has been watched by every human civilization that ever existed. It has been named, mythologized, navigated by, and admired for as long as our species has had eyes to see with. And we are, almost certainly, the first generation of humans who may actually see it die. Not in a textbook, not in a simulation, in the actual sky, with actual eyes, as something that has never happened in all of recorded human history is approaching. A nearby supernova, visible in daylight, altering the night sky for months, changing the constellation of Orion forever. It might be tonight, it might be in 1,000 years, it might be already happening right now, the light front racing toward us across 700 years of darkness, but it is coming. Look up while it's still there.